Howdy and good day, Algebra. We are covering the second page of PO61 Part 1, which is simplifying these radical expressions. And today, we're going to kind of tackle what to do with a variable. Okay, we've talked yesterday about just general roots. We talked about roots of fractions. You can kind of separate those. Today's focus is going to be on variables. And you're going to notice a pattern developing here. Okay, we've got the first several terms listed out, just exponent increasing by 1 here, but ultimately we want a rule for when the exponent of a variable is odd and a rule for when an exponent of a variable is even. So that when you're doing something like the root of x to the 14th, even though 14 isn't in this table, you're still able to do it. Okay, so the root of any variable, starting here. Okay, because we don't know what x equals, we don't know if we can take the root of it or not. X might be a perfect square, it might not be, it might be a fraction, it could be anything. Okay, so there's really nothing we can do when we have just the root of a variable. It's considered in simplest form, because without getting more information about what x is, no place to go there. Okay, however, when we take the root of x squared, things start happening. Because what do we know about the operation of taking the root and the operation of squaring? They cancel each other out. In this case, x can still be anything, right? We don't know what x is, but if we square x and then take the root of that, what are we going to be right back to again? X. So we've talked about before how a root and an exponent cancel out. The root of any variable squared is going to be x. Or if it's the root of y squared, it'll be y. Or the root of n squared is n. The root of any variable squared is that variable. Okay? So then we get to the root of x cubed. And kind of like yesterday, where we looked at how we can split apart roots into different factors. That's a horrible example. Something like the root of 75, how we can break that into factors, one being a perfect square. Oh my gosh. There we go. 25 times 3. We're going to do the same thing here. We can break apart x cubed to be the root of x squared times the root of x. Just digest that a little bit, okay? Just like how root 75 can be broken up into root of 25 times root 3, the root of x cubed can be broken up into the root of x squared times x. The reason why is because, 25 times 3 equals 75, right? What does x squared times x equal? Or x squared times x to the first? X cubed, right? Remember, those exponents are added when we multiply. We first learned about that back in PO44. So it's legal to do this. X squared times x is x cubed. And what do we like about this root of x squared here? What do we know about that based on what we just talked about 50 seconds ago? Yeah.
It cancels out.
It's a perfect square, technically, right? Just like how we have this perfect square factor here, we have a perfect square factor here. So that root of x squared becomes an x, and we have the root of x, that other factor we can't do anything with, kind of like this 3 here. This would simplify to be 5 root 3. This simplifies to be x root x. Whoa. Okay. So then we get to x to the 4th. Now, what are two factor pairs of x to the 4th? What are some ways we can multiply x's together to get x to the 4th power? Elise? X squared times x squared. And what do we like about x squared and x squared? Or the root of x squared, I'm going to move this over a little bit. The root of x squared and the root of x squared. What do we like about those? Evan?
They cancel.
They're both perfect squares, right? Those roots cancel out with the powers. So essentially, what we're left with, if we cancel out the root and the exponent on each of those, we're left with an x times an x, right? Cancel out the root and the power for each of those terms, and we're left with x times x, which equals x squared. Okay. Another way to think about it is if we look at, what times itself equals x to the fourth, well, x squared times x squared equals x to the fourth. So the root of x to the fourth is going to be x squared. Okay. Let's jump down to the root of x to the sixth now. We'll come back to x to the fifth in just a little bit. But as long as we're kind of riding this train here, how many root of x squareds go into the root of x to the sixth? 3 of them, right? We can rewrite the root of x to the sixth to be the root of x squared times the root of x squared times the root of x squared. Because 3x squareds are going to combine to make x to the sixth. And because we're taking the root of x squared, we're able to cancel out our root and power there, cancel it out here, cancel it out here, and what are we left with? X times x times x, or x cubed. How about x to the eighth? How many x squareds can we take out of x to the eighth? 4 of them, right? Root of x squared times the root of x squared times the root of x squared times the root of x squared, right? 2, 4, 6, 8. We can cancel out our radical and power on each of them, and we're left with x times x times x times x, or x to the fourth power. Like I said, our goal here is to find a rule for what to do when the exponent on our variable is even. Do you see any patterns developing? Josh? Right. When you have an even power on your variable, it's going to be that power divided by 2. And your root sign is gone. Okay? So rule from the exponent of a variable is even. We're going to divide power by 2. Okay? Divide power by 2. Or another way to think about it is the root of any variable to the nth power, as long as n is even. This is going to be equal to that variable to the half of n. Okay? If you're more of a symbolic variable kind of person, that equation might resonate with you more. If you like the words, you're essentially dividing the power by 2. So when we have something like the root of x to the 14th power, I don't want to have to write that all out in this big old table here. We've got a rule now. What is the root of x to the 14th power going to equal? X to the 7th. There you go. Okay? Follow so far?
Yes.
All right. Because once you get that rule for the even powers, the odd powers, which bring a little bit something different, but we can work with them now. Because that root of x to the 5th, instead of saying how many x squareds I can pull out of here, I know that x to the 4th is a perfect square. So I'm going to rewrite x to the 5th as the root of x to the 4th times the root of x. Right? This works because 4 plus 1 equals 5. You know, it's a legal breakdown of the root of x to the fifth. But the reason why I do this is because what do I already know about the root of x to the fourth? What does that equal? X squared. And then that extra term that I can't do anything with, like we saw on the first page, was it root 3 or root 5 or root 7 or just root x, that just, not that one, that just tags along. So we have x squared root x. The root of x to the seventh. I know that a x to the sixth can come out of there. And if I pull out the root of x to the sixth, I'm left with what? The root of x. So I kind of turn an odd exponent into an even one with an extra one added on, right? Because to get 7, I've got 6 of them plus 1. That gives me the 7. And what do I know about the root of x to the sixth? Since it's an even power, I can just divide it by 2. And so I've got my x cubed here. And then I add on my additional root x. So every time you have an odd power, you're always going to have a root x tagged along at the end. But we still want to use that kind of idea of the even powers to help us. So how would you verbalize that? The rule from the exponent of a variable is odd. What do? If we have x to the n here, where n is odd, what do we kind of do here? What is the exponent on our answer term become? Yeah?
You separate it into an even number and 1, I guess.
Essentially what we did here was we took our exponent, divided it by 1, subtracted by 1, and then divided that by 2, right? When we had a 7, we subtracted 1 to get 6, divide by 2, there's our 3. When we had 5, subtract by 1 to get 4, divide by 2, there's our 2. Okay? If we had the root of x to the ninth, subtract by 1 to get that x to the eighth, divide by 2, it'd be x to the fourth, and then we have a root x that tags along with it. Okay? So a little more complicated than when our power is even here, but what we're doing is we're separating it into an even power, always one less, times the root of x, so that we can then divide that power by 2 to get our leading coefficient here, and then have that root x carry on. So I don't have a good one here. Let's pretend that this, since we already have this one in the chart here, let's pretend this was x to the 19th power. What's that going to be when we simplify it? We're going to subtract 1 from the power. That gives us the root of x to the 18th times root of x. And since that power is even now, what do we do to get rid of the root? Divide by 2. So that's going to give us x to the ninth. The root's now gone. And then we have that extra root x that's taken along. So x to the ninth root x. How's that sitting? Okay? We good? More or less? Okay? Practice a little bit? All right. So let's look down here, and we've got several to discuss. Fractions, multiple terms in an expression, lot going on here. So let's just start at the top. Root of x to the 12th. What do we get? X to the 6th. That even power makes it really, really nice. Just divide by 2. And again, the reason why that works is because how many x squareds make x to the 12th? 6 of them. each one of those root of x squareds is just an x. So if we have 6 root x squareds, we have 6 x's, x to the 6th. The shortcut, just divide the power by 2. The next one, a fraction. Okay, I know that I can split this up to be the root of y to the 9th over the root of 49. I still like that my denominator, enjoy this while it lasts, folks. Enjoy this. That denominator being a perfect square puts us in our happy place. And then the root of y to the 9th, okay, again, kind of our process here is we're going to separate that up into the root of y to the 8th, get that even power, because we like to work with that, times the root of y. So then the root of y to the 8th, since it's an even power, we can divide that by 2. We get y to the 4th. The root y tags along. And we get y to the 4th root y over 7. And we already did x to the 5th and root of x to the 14th. Questions popping up as we work through these. Noah? Oh, we'll do more. Oh, we're not done yet. Because, yeah, I keep throwing things at you. We're building this, right? Every line kind of adds something new here. In this next line, the root of 8x squared, now not only do we have a variable, but we have a coefficient as well. So our first step is we're going to split this up into its coefficient and its variable and deal with them separately. Because coefficients and variables, while they follow similar rules, it's just a little bit different process because we don't know what x equals. So if we're split this up, root of 8 times root of x squared, and let's deal with the root of 8 first. Can I simplify root 8? And if so, how? Elise? Right. This goes back to the first page. Pull out that perfect square factor. Root 4 times root 2. My root 4 becomes a 2. Right? That's why we want that perfect square factor. My root 2 can't do anything with that. And so I'm done with my coefficient. How about my root of x squared? What do I know I can do with that? What does that equal? Noah? Just x. So this I can bring all the way down. There's no middle step here. All the way down, and that just becomes an x. To put this all together now, what is outside of a root is placed in front, my 2 and my x. What's inside of the root stays under the root. And that's my final answer. Remember when math made sense? Remember those fun times when you could see how you got from one thing to the other? Like you bring this home to your parents tonight or whatever, they're over your shoulder, watch you work on your homework, and it's like, oh, okay, have fun with that, kids. Right? If you're not already there, we're reaching the point where most parents would not be able to help anymore. So you're on your own, except for those great YouTube videos that you should like and subscribe to, or older siblings, sir. Let's skip to the third one here. Let's skip over the fraction for now, and let's look at another one where we've got a coefficient and a variable. Just like this example that we just did, we're going to start by splitting this up. Coefficient and variable separately. Deal with them individually rather than as a whole. So we look at the root of 32, and we're going to simplify that just like we did on the front side, or the first page. What are our factors of 32, one of them being a perfect square? Ideally, the largest perfect square, just to minimize the work that we need to do here. Emily? 16 and 2. If you were thinking 4 and 8, you aren't wrong, but that 8 could be simplified further. So the most efficient way to do this is root 16 times root 2. We like the root 16 because it's a perfect square. The root of 16 equals 4. And again, we're left with that root 2 that we can't do anything with. But our coefficient is now done. So we go to our x to the 7th. We know what the rule is. Maybe we can do it mentally. But essentially, the math behind the rule is that we are rewriting this to be the root of x to one number less, x to the 6th. Get that even power. And then the root x is my leftover factor, because x to the 6th times x is x to the 7th. But I want that even power, because what's the root of x to the 6th? Gabby? X cubed. I like that even power, so all I have to do is divide by 2, and the root is now gone. The root of x, well, can't do anything with that, so it's left as root x. Okay? So I'm trying to make this as kind of straightforward, as easy to follow as possible. We've got our root 32, which I break into its two factors, that root 16 being the perfect square. Take the root of that, that's where the 4 comes from, and the root 2 is left over. The root of x to the 7th, I break it down into that x to the 6th times x. Just subtract 1 from the power. The root of x to the 6th equals x cubed, and I got my root x that hangs over. So, putting it all together, again, what's outside of the root goes together outside of the root, 4x cubed. What's inside of the root goes together inside of a root, 2x. Okay? So I've got 4x cubed out in front, root 2, root x, root 2x. And there's my final answer. How are we doing?
I'm doing great.
Okay? This is, yeah, all right. Let's go to the fraction one here. The root of 15x cubed over the root of 4y squared. And as these fractions get more and more involved, I really like that we can split this up into the root of 15x cubed over the root of 4y squared and deal with them separately. And again here, folks, enjoy it while it lasts. What do you notice about your denominator here? It's a perfect square. I'll do it over here. What times itself equals 4y squared? Which is what the root's saying here, right? What times itself equals me? What times itself equals 4y squared? 2y. 2y times 2y equals 4y squared. Or you can think about it, the root of 4, our coefficient, equals 2, and the root of y squared equals y. All right? So yet again, we have a perfect square denominator, which means we only got to deal with that numerator, and I'll do that kind of down here. So we've got the root of 15x cubed, which we're going to rewrite as the root of 15 times the root of x cubed. Deal with each of them separately. Root 15, can I do anything? No. Its only factors are 3 and 5. Neither of those are perfect squares. There's nothing I can do. Sorry, root 15. You're just going to stay that way. Well, not useless, but... Yeah. The root of x cubed, we've got the answer in our chart up above, but the work behind it is we're going to split this up into root of x squared, just one less than our power, times the root of x. We do that because the root of x squared is x, and then we have our root x. So what's outside of the root? Just an x. what's inside the root? This root 15 and our root x. Our final answer is x root 15x over 2y. Please stop me if you're getting lost in the process. It's okay. Okay. That fourth one, the root of 25x to the fifth over y to the fourth. Again, I'm going to break this up into numerator and denominator. Again, I smile because I see that the denominator is a perfect square. The root of y to the fourth, even power, just divide by 2, we get y squared. That numerator, the root of 25x to the fifth, I'm going to do the work down here. I'm going to split it up into its coefficient and its variable separately. So root 25 times root x to the fifth. The root of 25, hey, look what we got. What is that? A perfect square. Thanks, math. That's just going to be 5. And then the root of x to the fifth, we see the work up in our chart up above, but essentially we're going to decrease that power by 1. So we get that even power there. And then we simplify that by dividing by 2. So it's going to be x squared, and the root's now gone. So what's outside the roots? Our 5 and our x squared go together. And what's inside the root? The x is there. 5x squared root x over y squared. Give me something. We're doing okay? Thumbs up for the most part? Okay. Okay. Bottom row. Pick which one you'd like to do together. Now we're at our next level here. We have a coefficient and multiple variables. Yes, Quinn. Sure.
Can I go for the one?
Oh my goodness. Yes, sure.
Yes.
Everyone just leave. No. Which one would you like to do together? Brady. Sure. The root of 18 x cubed y cubed. So like the others, I'm going to start this by splitting up my coefficient and then each variable base. Okay? I'm going to deal with each one separately. 18, x cubed, y cubed, all separate. Starting with our 18, what's our combination here? What's what are our two factors? Alex? 9 and 2, 9 being that perfect square. So root 9 times root 2. I like that root 9 because it simplifies to be 3. And then root 2 just tags along. I'm going to spread this out a little bit, actually, so I have some more room to write here. Ugh. Okay, so that root of x cubed now, I'm going to split that into the root of x squared times the root of x. Just subtract that power by 1, get that even power. The root of x squared is a perfect square. That becomes an x. And my root x I can't do anything with. Same thing for my root y now, right? Just because the variable changed doesn't really make a difference. I've got that y cubed, so I'm going to subtract the power by 1 to get my root of y squared times the root of y. And it really ends up being the same thing as my x term here. What's the root of y squared? Somebody, what's the root of y squared? Julia, because I asked. I saw your hand up, but I didn't want to call on you again because I already got you with that joke. Okay. It is just y. And then the root y follows along. So now, what's on the outside of the root? This 3, that x, that y. So we've got 3xy all together. And what's inside the root? 2 root x, root y. Hey, what's the root of 18x cubed y cubed? Oh, it's 3xy root 2xy. What? Okay. There you go. Okay. The other 3 I'd like you to try on your own for homework for tomorrow. Okay. Remember tomorrow, actually for Monday, because tomorrow is going to be a retake day. So for Monday, you can do 1 tomorrow, 1 Saturday, 1 Sunday, and be finished in time. Questions, comments, concerns, complaints, comments, congratulations, or criticisms on this? Soybe?
Oh, I just want to say congratulations.
Thank you, Soybe. I appreciate it. 1 Saturday, 1 Sunday, 1 Monday morning would also work, but yeah. All right, folks, that's how you math.
Don't forget to like and subscribe.
Whoops, hold on. There we go.